10 tons of TNT just detonated 28 miles above your head, and nobody on Earth saw it coming. Not NASA, not any telescope, not any warning system, nothing. The blast lit up the sky across 4 separate J jurisdictions: Washington State, Oregon, Idaho, and the Canadian province of British Columbia. 5 volcano monitoring stations in the Cascade Mountain Range recorded the shockwave, and the people whose job it is to watch the sky for exactly this kind of thing had absolutely no idea it was about to happen. Not 1 second of warning. That's where this story starts. It's not where it ends. Because when you dig into what the instruments recorded, when you run the actual numbers NASA published, and when you look at what is BN quietly building in the data for the first half of this year, you find something scientists themselves don't yet have a clean explanation for. We're going to walk through every piece of it, step by step, right now. It was 12:48 in the morning on Friday, August 14th, 2026, Pacific Daylight Time. Most people in central Washington were asleep. The annual Perseid meteor shower was still active. It had peaked the night before, so a few dedicated skywatchers were probably still outside with their eyes up. But nobody was watching for what actually came. At 12:48 a.m., a piece of asteroid entered the atmosphere over eastern Washington and began to glow. It first became luminous at an altitude of about 48 miles, 77.9 kilometers, directly above a small town called Soap Lake in Grant County. From that moment, it had about 4 seconds of existence left. It was traveling north at 32,800 miles per hour, 14.6 kilometers per second. It crossed 36 miles of upper atmosphere in that time, moving in an almost perfectly straight northward line, and then it came apart. It fragmented at an altitude of 28 miles, 45.5 kilometers, above a location in Douglas County called Sims Corner. When it came apart, it released energy equivalent to 10 tons of TNT. Let that number sit for a second. 10 tons of TNT detonated silently above the Columbia Basin while most of Washington slept. The flash was seen from 4 jurisdictions. People across the Spokane area woke up. Residents checked their doorbell cameras and found the light already captured. A brilliant blue-white streak across the sky, bright enough to wake people up whose curtains were closed. One resident in Spokane Valley told a reporter he initially thought something had happened at a neighbor's house. It took him a moment to realize the light had come from the sky. 266 reports flooded into the American Meteor Society's Fireball Rep reporting system by Friday. 27 separate video recordings were submitted. Traffic cameras in both Bellevue and Spokane caught the event on tape. It was one of those rare moments when the sky does something so dramatic, so sudden, that an entire region stops and asks, "What was that?" Then the scientists started working backwards to figure out exactly what happened. NASA drew on 3 separate data streams to reconstruct the event. The first was those 266 eyewitness accounts from Washington, Oregon, Idaho, and British Columbia. Ordinary people describing what they saw, where it appeared, which direction it moved, how long it lasted. The second was footage from a handful of publicly accessible cameras that happened to be pointed at the sky at the right moment. Not a dedicated fireball network, just cameras that were there and happened to catch it. The third source is the most interesting one, and nobody designed it for this purpose: the geostationary lightning mappers aboard the GEOES weather satellites. Here's why that matters. The GEOES satellites sit in geostationary orbit about 22,000 miles above Earth. Their job is to map lightning. They watch for optical flashes at a very specific wavelength, 700 to 7.4 nanometers, which is the wavelength produced by energized oxygen atoms. It turns out a rock exploding in the upper. Our atmosphere produces almost exactly that kind of flash. When a meteoroid hits the atmosphere at high speed and begins to burn, the superheated air around it glows at the same wavelength these lightning instruments are to need to detect. So the same satellite system built to warn meteorologists about thunderstorms became one of the primary tools for reconstructing the flight path of a beach ball-sized rock from space. Nobody planned that. Physics doesn't care what an instrument was built for. This isn't the first time it's happened this way either. Earlier this year in May, a daylight fireball broke up over New England and was caught the same way by a weather satellite's lightning detector. The pattern keeps repeating. The dedicated planetary defense systems didn't catch it. The improvised, repurposed systems did. Hold on to that thought. It comes back in a big way later. Now here's the part of this story most coverage skipped past, and it shouldn't have. The volcano stations. When the object fragmented 28 miles above Sims Corner, it produced a pressure wave, technically an infrasound wave. Infrasound is sound, but at frequencies below what the human ear can detect. It travels at roughly the same speed as audible sound, about 0.34 kilometers per second near the surface. And this particular wave was powerful enough to travel hundreds of miles in every direction from the explosion point. The wave arrived at 5 different U.S. Geological Survey infrasound monitoring stations, all installed on the flanks of Cascade Range volcanoes: Glacier Peak, Mount Rainier, Mount Adams, Mount St. Helens, and Mount Hood in Oregon. The signals arrived at those stations between NT 1255 and 1:10 in the morning Pacific time, roughly 7 to 22 minutes after the 1248 explosion. That delay isn't mysterious. Infrasound travels at the speed of sound, so the farther a station sits from the blast, the longer the wave takes to arrive. The stations sit between roughly 140 and 440 kilometers from the explosion point, and the arrival times match exactly what you'd expect from an airburst at that location. The numbers line up perfectly. But stop and think about what those stations actually are. They're volcano monitors. They're bolted to the flanks of Cascade volcanoes, specifically to listen for eruptions, rockfalls, lahars, river, of volcanic mud, and gas jets. They exist because Mount St. Helens killed 57 people in 1980, and the agencies responsible for public safety decided they'd rather know when the next eruption was coming than find out after the fact. Those instruments were installed to listen for threats coming from inside the Earth. On the morning of August 14th, 2026, they heard a threat coming from space instead. Here's the detail that's almost poetic. The Cascades Volcano Observatory issued its routine weekly update at 11:06 that same morning, just hours after the event. That update confirmed every monitored volcano in the Cascade Range remained at normal background levels. In the space of a few hours, that observatory had to notice an unusual pressure signal appearing simultaneously on 5 of its own stations, determined through analysis that it wasn't volcanic in origin, correctly attribute it to an atmospheric airburst, and communicate that publicly. They did all of that correctly and fast. But the deeper point stands. There is no dedicated national infrasound network in the United States built specifically to detect incoming bolides. What exists is a patchwork. The International Monitoring Network originally built to detect illegal nuclear weapons tests, a hand full of university research arrays and volcano stations like these 5. This event was recorded in unusual detail because it happened to explode directly over a volcano observatory's listening range. An identical object exploding over the Great Plains would have been detected by far fewer instruments. As the people who study this have put it plainly, we measured this one by luck. Now let's talk about the object itself, because the numbers NASA published are fascinating, and one of them doesn't add up in a way that's worth actually understanding. The object was approximately 16 inches in diameter, about 40 centimeters, roughly a beach ball. It weighed approximately 170 pounds, 77.1 kilograms. It was moving at 14.6 kilometers per second. The energy released when it came apart was 10 tons of TNT equivalent. Take those first 3 numbers and run the physics. Kinetic energy equals 1/2 times mass times velocity squared. Half of 77.1 kilograms times 14,600 meters per second squared. That gives you rope. Gertlai, 8.2 billion joules. 1 ton of TNT is about 4.184 billion joules. So the total kinetic energy of this object at this speed, every bit of it converted with perfect efficiency, works out to about 1.96 tons of TNT. Call it 2 tons. Those two numbers differ by a factor of 5. Work it backwards. If you start with an airburst of 10 tons of TNT and ask what mass would need to be traveling at that speed to produce that energy, you get about 392 kilograms, more than 5 times the published mass of 170 pounds. The most plausible natural explanation for the anti-Helian directional excess is a stream of debris from a relatively recent asteroid breakup. A collision or rotational failure somewhere in the inner solar system that scattered fragments along G and orbit Earth is currently passing through. That would be new science. It wouldn't require anything hidden or mysterious. It would be a perfectly natural phenomenon that simply hasn't been documented before, because the monitoring network that would catch it is still being built. And that points to something important about how exposed we actually are. The planetary defense surveys currently operating are calibrated to find objects 140 meters and larger, the size class that threatens a region rather than a rooftop. The object over Washington was about 16 inches across, roughly 0.4 meters, approximately 340 times smaller than the floor those surveys were designed to reach. It wasn't merely undetected. With the instruments that currently exist, it was undetectable right up until the moment it started glowing in the atmosphere. There was no warning possible. There was no warning given. There was no warning to give. NASA's own Planetary Defense Office has acknowledged that even at the 140-meter threshold they're designed for, only about 40% of that population has been cataloged. Roughly 15,000 objects in that size range remain undiscovered, even at the scale we're actively trying to monitor. Below that threshold, at the size of the Washington object, at the size of the rock that detonated over Chelyabinsk, Russia in 2013, Releasing 500 kilotons and injuring over 1,000 people, coverage is essentially zero. Let's be precise about what the August 14th event was not. It was not a satellite re-entering. Orbital hardware comes down at roughly 7 to 8 kilometers per second, because that's orbital velocity. This object was measured at 14.6 kilometers per second, roughly double. You can not reach 14.6 kilometers per second from Earth orbit. You can only get there on an orbit around the Sun. Re-entering orbital hardware also behaves differently. It fragments into a long, slow train of separating pieces visible for tens of seconds, sometimes more than a minute. The August 14th object was one body, 4 seconds of visible flight, one fragmentation event, one sonic boom. The physics isn't remotely close. What it was a rock, a beach ball-sized piece of asteroid, possibly porous and carbon-bearing based on the density numbers, traveling on a prograde inner solar system orbit, caught by Earth's gravity, vaporized in the upper atmosphere, and turned into a 10-ton explosion 28 miles above the Columbia Basin while most of Washington slept. There may be pieces of it on the ground right now. NASA's release stated that Doppler weather radar indicates some small meteorites may have reached the surface in the area. Falling meteorites show up on weather radar as small, non-meteorological echoes, a cluster of Ret 2 RNs drifting slowly downward in the minutes after an airburst. And those returns can localize a strewn field to within a few kilometers. Early speculation from Meteor researchers pointed to the area around Bridgeport and Brewster. NASA's terminal point puts the final frag, mentation above Sims Corner. All of these locations sit in Douglas County, open shrub steppe and dryland wheat country in the channeled scablands north of the Columbia River. For hunting dark rocks against pale ground, that's actually unusually good terrain. But as of right now, no recovery has been announced, and that's worth saying clearly. The absence of an announcement isn't evidence something's being withheld. Most meteorite searches produce nothing. These are small, dark rocks in a very large landscape. If fragments are recovered and analyzed, the classification of those stones will answer several open questions at once. If they turn out to be ordinary chondrites, the most common type in the catalog, accounting for the majority of known meteorites, the story ends as a well-documented but ultimately unremarkable fall. But if they turn out to be something rarer, specifically the Head family, Howardites, Eucrites, and Diogenites, a class associated with the large asteroid Vesta, that put this object in the same category as 2 rare recoveries that landed just 9 days apart back in March. A suspected Diogenite from a daylight bolide over Europe on March 8th, and a confirmed Eucrit from the Ohio Fireball event on March 17th. 3 head recoveries inside 10 days, against a global baseline of about 10 per year across all types, would be the hardest physical evidence yet that something unusual is arriving from a specific direction. That thread has never been satisfactorily explained. Laboratory analysis of the Washington stones, if found, would either add to it or close it. For perspective on scale, this was a modest event by the standards of significant bolide events. In March, the Ohio Fireball involved an object of roughly 7 tons, about 2 meters across, releasing around 250 tons of TNT equivalent. The Houston Fireball, 4 days later, involved about a 1-ton object, broke up 29 miles up, released about 26 tons of energy, and dropped a fragment through somebody's roof. The Washington event on August 14th, at about 170 pounds and 10 tons of energy, was the smallest of that recent trio by an order of magnitude. It still lit up 4 jurisdictions and rang 5 volcano monitoring stations across 2 states. So here's where everything stands right now. As of August 17th, 2026, a piece of asteroid detonated over Washington 3 days ago. Nobody saw it coming. The volcano monitors in the Cascades heard it before any dedicated space-watching system could. The energy NASA published is mathematically inconsistent with the mass NASA published, in a way that points to genuine measurement uncertainty rather than anything sinister. The object's direction, speed, and orbital profile are consistent with the anti-Helian source, the same region of sky that produced a 4.1 sigma excess of fireballs in the first quarter of this year in the American Meteor Society's dataset. No recovery of fragments has been announced yet from Douglas County, but the search is plausible. Even the terrain, and the question of whether we're seeing a temporary increase in material from that part of the sky, possibly a debris stream from a recent asteroid disruption, remains genuinely open. The directional signal in the data exists, it hasn't been explained, and the null result paper from July, while legitimate on its own terms, didn't test the thing that matters most. What this event proves, more than anything, is the gap between the scale of the universe and the scale of our watching. A rock 16 inches across, weighing less than a typical motorcycle, traveling on an orbit around the sun for millions of years, entered Earth's atmosphere 3 days ago, and nobody on the planet had any idea it existed until the moment it started glowing. We found out about it through doorbell cameras, traffic cameras, weather satellites repurposed as meteor detectors, and infrasound instruments installed on volcanoes. That is the state of planetary awareness in 2026. And as the people who study this have said with complete honesty, the next one will also arrive without warning. Not because someone failed, not because something was hidden, but because the aperture of our watch on the sky is smaller than most people know, and the universe is very, very large. The next one is already out there somewhere. We just can't see it yet.